Today we're going to look at finding solutions by graphing. Remembering that y equals mx plus b is the equation for a line. If the equation is already in that format, all we have to do is graph it. So looking at the solution for the system of equations for y equals 3x minus 6 and y equals negative x plus 6, let's graph the lines. We know that we start here with negative 6 because that is the y-intercept. So on the y, we're going to go to negative 6. 1, 2, 3, 4, 5. Here's negative 6. And from there, we're going to count slope. Slope is 3, so we're going to go up 3 and over 1. That is 1 point on the line, and negative 6 is another point on the line. So now we can connect those 2 points. And that is the line represented by the equation y equals 3x minus 6. So if we look at our other equation in this system of equations, it's y equals negative x plus 6. This time we're going to start at positive 6. 1, 2, 3, 4, 5, 6. That is 1 point on the line, and from there we're going to count slope, which is negative x. Well, negative x, remember, always has a 1 in front of it, so we're looking at negative 1, which means for slope we need to rise over 1, down 1, over 1, and this must be another point on that line. When we draw that line, connecting those 2 points, we'll see that there is 1 point of intersection. And where these 2 lines cross is where the solution of the equations is. And we can see that it crosses right about, well, it's supposed to cross right about here. I just didn't draw my lines very well. It's hard to do on this screen. So the point of intersection on your paper should be 3, 3. Now, that's saying that the solution, the value of x and the value of y that will make this equation true is when x is 3 and y is 3. So now we're going to replace the now known values of the variable. If I look at the first equation, y equals 3x plus 6, we're now saying that x is 3 and y is 3. So I'm going to replace y with 3, and I'm going to replace the x with 3, and then I'm going to solve the equation. 3 equals 3 times 3, which is, oops, this is minus 6. This should be, sorry, this should be minus 6. 3x minus 6. Oops. So if I'm rewriting it now with x is 3. 3 times 3 is 9, and 9 minus 6 is 3. 3 equals 3, check. So we know that when x is 3 and y is 3, it makes this equation true. So let's now try that with the other equation in this system of equations, which is y equals negative 1x plus 6. I'm now going to replace x with 3 and y with 3, because we said that was the solution. Y gets replaced with 3, x gets replaced with 3, and now we solve. Negative 1 times 3 is negative 3, and negative 3 plus 6 is 3. So that is a true statement. So we know that the solution to the equation is 3, 3. And we can see that by where they intersect on the graph. Let's try another one. Here we have a system of equations. Y equals 3 halves x plus 1, and y equals negative x plus 6. These are both already in y equals mx plus b form. That's important because I need to know where to start. I start at the y-intercept. For this equation, I'm starting at positive 1 on the y-axis, which is right here. That is 1 point on the line. To describe the line for y equals 3 halves x plus 1. So from there I'm going to count slope. Well, slope is rise over run, right? It's always in front of our variable. So we have 3/2 x. So I need to rise 3 and run 2, making another point on the line right here. If I can draw this as carefully as I can to connect those 2 points, that line is represented by y equals 3/2 x plus 1. Now, let's try the other equation. Y equals negative x plus 6. Right, we need to start at positive 6. We know that that's 1 point on the line. 1, 2, 3, 4, 5, 6. Because that's the y-intercept. And then we need to, from there, graph slope. Well, again, we have a negative x. Negative x is the same as negative 1x. So we're going to go down 1 over 1, down 1 over 1. And we know that's another point on the graph. I can go again, down 1 over 1, down 1 over 1, down 1 over 1. And that has to be the line. Now, something interesting happened here. We can see that 2 points cross right here. So their ordered pair is 1, 2, 1, 2, 3, 4. 2, 4, which means this must be the solution to the equation. So let's check if 2, 4 is the solution to the equation. I'm going to go back to my first equation, which was y equals 3/2 x plus 1. And I'm going to replace the now known values of the variable. This is the value of x, and this is the value of y, and it should make my equation true. So if y is 4 and x is 2, I now have this. And when I solve, 3/2 times 2 is 3 plus 1, 4 equals 4. Check. That is a true statement. Let's look at the second equation in our system of equations, which was y equals negative x plus 6. Again, we're saying that y is 4 and that x is 2. So let's see what happens. 4 equals, well, negative 2 plus 6 is 4. Therefore, we know this is the solution to our system of equations. All right. In this next case, you'll see something a little different because we have two solutions in our system of equations, but they're not in y equals mx plus b form. So we're going to have to put them in y equals mx plus b form. Now, what's out of place in our first equation is the x. So we need to move x to the other side, leaving us with 2y's on this side, a negative x on this side, and a positive 4. Remember, x's and 4's don't go together. They're constants and variables. I'd like to get y alone, which means I'm going to have to divide by 2. If I divide this side by 2, everything on the other side needs to be divided by 2. And that leaves us with y equals negative 1/2 x plus 2. Because, remember, there's a 1 in front of this x, and we're just going to leave it a fraction. Negative 1/2 x, and 4 divided by 2 is 2. Now, we can graph this line. Now we know that we can start on the y-axis at 2, right? And then we're going to go down 1 over 2. That's our slope, down 1 over 2. Here is the line represented by the equation y equals negative 1/2 x plus 2. All right, let's look at the other equation. We have 2x plus y equals 8. Well, we can't graph it because we don't know where things are. It's not in y equals mx plus b. So we need to move the 2x's to the other side, leaving us with a y on this side and a negative 2x plus 8 on the other side. So now it's in y equals mx plus b form. We know that we can start at 8. That's our y-intercept. So I count up 8. 1, 2, 3, 4, 5, 6, 7, 8. And from here, I'm going to count slope. Well, slope is negative 2 or negative 2 over 1, because slope is always rise over run. So we're going to go down 2 over 1. This must be another point on the line. If I wanted to, I could go down 2 over 1 again. I can go down 2 over 1 again. This is going to consistently happen, down 2 over 1. and I'll see that this line is going to cross right here. The red line and the blue line cross right here at 4, 0. So I'm thinking that 4, 0 will be the solution to our equations. It looks like 4, 0 will be the solution to our equations. Well, as you know, we can check. If I look at the first equation, which was y equals negative 1/2 x plus 2, I now know that x is 4 and y is 0. X is 4, y is 0. And if we solve, half of 4 is, sorry, this is negative. Negative 1/2 of 4 is negative 2. And 0 equals 0, right? Negative 2 plus 0 is 0. Check. If we look at the second equation, which was y equals negative 2x plus 8, and I'm now replacing, this is the value of x, this is the value of y. We're saying that y is 0, x is 4, and if we solve, negative 2 times 4 is negative 8, and negative 8 plus 8 is 0. So we can see that the solution to the equation is indeed 4, 0. It is the point of intersection where the two equations meet. All right, now you try it. Here's 2 examples for you to work out on your paper. When you're done, take a screenshot of all of your notes, including numbers 4 and 5, and submit for credit.